Good morning students. Welcome back to Maths Online class. How are you students? I hope you are fine and safe by God's grace. Students, have you all completed your homework? I hope you all have completed your homework. In the previous class, what did you learn students? Yeah, you have learned about relation, is it? Today I am going to explain about the function. Today I am going to explain about the function. Students, already you have learned relation. What's the definition for relation? What's the definition for relation? Relation is a subset of Cartesian product. Is it? Shortly, if you are saying that is relation is a subset of Cartesian product. Is it? Now, function is a which one? Subset of relation. Function is a subset of relation. Now, I am going to explain the definition for function. Function, a relation f between two non-empty sets. Okay, a relation f between two non-empty sets x and y. X and y is called a function from x to y if for each x belongs to x, for each x belongs to x, there exists only one y belongs to y such that x comma y belongs to f, such that x comma y belongs to f. Now with example I am explaining this. Okay, what is the function? Function is a subset of relation, is it? What is the definition for function? A relation f between two non-empty sets x and y is called a function from x to y if for each x belongs to x there exists only one y belongs to y such that x comma y belongs to f. Listen, that is in the shortly when we are saying x comma y, it is a subset of Cartesian product. For all x belongs to x, y belongs to y. X belongs to x, y belongs to y. Now with one example I am explaining this. First, x, set x is equal to minus 3, minus 2, minus 1, m. Next, set y is equal to 1, 2, 3. This is set y. With the arrow diagram I am explaining. One relation I am giving here. Minus 3, 1, minus 2, 2, minus 1, 1, m, 2. It is one of a relation. It is one of a relation. Here, already you have learned what is the image of minus 3. Here already learned domain is equal to set x. Set x is called domain. Is it students? Set x is called domain. Domain is equal to minus 3, minus 2, minus 1, m. Next, codomain is equal to 1, 2, 3. Okay. Now everything x belongs to x, that is minus 3, minus 2, minus 1, m belongs to x, so that is domain. Codomain is equal to 1, 2, 3. Now image of minus 3 is, image of minus 3 is 1. In the relation itself you have learned, is it image of minus 3 is 1. Next, image of minus 2 is 2. Next, image of minus 1 is 1. Next, image of m is 2. Is it? Every element in x having a image. Every element in X having a image. Is it, students? Every element in X having a image. So we can say it is a function. That also every element having a unique image. Here also minus 3 having a image 1. Next minus 2 having a image 2. Minus 1 having a image 1. M having a image 2. So we can say it is a function. Okay. So it is a function. When we can say it is not a function, with another one example, I am explaining that when we can say that is not a function. One example, one set X is A, B, C, D. Set Y is X, Y, Z. One of the relation is A, X, B, Z, D, Y. Okay. Another one example. Here it is not a function. It is not a function. Why it is not a function? Listen. What is the image of X? Image of A, X. Image of B, Z. Image of D, Y. C does not have a image. C does not have a image. Any elements in X does not have a image means that is not a function. Any elements in X does not have a image means that is not a function. Okay. The elements in Y does not have a pre-image means also function. Okay. Don't see here. Here sometimes here is a. Now is it a function? Yes, it is a function. This L does not have a pre-image. Is it L does not have a pre-image even though it is a function. The elements in X does not have a image means that is not a function. The elements in Y does not have a pre-image means also a function only. Okay, clear, students? Once again, I am explaining the definition. A relation F between two non-empty sets X and Y is called a function from X to Y if for each X belongs to X, there exists only one Y belongs to Y, such that X, Y belongs to F. That is, F is equal to X, Y for all X belongs to X and Y belongs to Y. Next, the function F from X to Y is written as F from X to Y. F from X to Y. Function can be written as F from X to Y. Next, functions are subsets of relations. Functions are subsets of relations. Relations are subsets of Cartesian product. That already you have learned. Relations are subsets of Cartesian product. The functions are subsets of relation. Clear, students? Listen. The functions are subsets of relation. The relations are subsets of Cartesian product. The relations are subsets of Cartesian product. Now, I am going to give some note. If F from X to Y is a function, then the set X is called the domain. Already I have explained. The set X is called the domain. Here, F from X to Y is a function. The set X, this is called a domain and of the function F, and the set Y is called a codomain. Set Y is called a codomain. Clear? This is domain. Domain is equal to minus 3, minus 2, minus 1 m. Y is equal to 1, 2, 3 is a codomain. Next, If f of a is equal to b, then b is called a image of a. B is called a image of a. That only I have explained. Image of minus 3 is 1. Image of minus 2 is 2. Image of minus 1 is 1. Image of m is 2. Clear? That is a image. Next, image under f. Image of a under f, and a is called the pre-image of b. A is called this everything called the pre-image of which one? Y. Now we can say pre-image of 1 is what? Minus 3 comma minus 1. Pre-image of 1 is equal to 1 is minus 3 comma minus 1. Next, pre-image of 2 is minus 2 comma m. Clear? Minus 2 comma m. So, okay, clear students? B is called a image of A under F and A is called a pre-image of B. Next, the set of all images of the elements of X under F is called the range of F. The set of all images of the elements X under F is called a range of F. Now, in this example itself, listen students, here images of minus 3 is 1, images of minus 2 is 2, images of minus 1, image of minus 1 is 1, image of m is 2. This everything, this 1 comma 2 is the range of this function. Range is equal to what? Range is equal to minus 1 comma 2. Clear? Range is equal to 1 comma 2. Okay. All the images together is called a which one? Range. Clear? This 3 is in the set Y, but it is not in range. Why it is not range? This 3 does not have a pre-image. What are the elements in Y having a pre-image only? Which one? Range. The elements does not have a pre-image means that is not a range. Clear students? Okay. Next, f from x to y is a function only if every element in the domain of f has an image. Every element, before example itself I have explained, every element in x having a image. That's why it is a function. The elements in y does not have a pre-image means also a function. Like that I have explained, is it? Every element in x having a image, so it is a function. That only given in the note. F from x to y is a function only if every element in the domain of x, f has an image. Every element have the image. The image is unique. The image is unique. Now the image of minus 3 is 1. The image of minus 2, which one? 2. Image of minus 1, 1. Image of m is 2. Any element in x have a 2 image. Any element in x have 2 image? No. Sometimes this m having 2 image means now the m having 2 image, that is 2 comma 3. Now it is not a function. The elements in x, everything should be a function, should have the image. that also unique. Now M have two different images 2, 3. So it is not a function. Okay, that only given in here. The image is unique. If the image is unique means only that is a function. Clear, students? Listen. If A and B are finite set, A and B are finite sets such that n of A is equal to P, n of B is equal to Q, then the total number of functions that exist from A to B is Q power P. Okay, it is very important note. N of A is equal to P, n of B is equal to Q means total number of functions between A and B is Q power P. Okay, suppose the set A having two images. A have two elements. A is equal to 1, 2. B is equal to 3, 4, 5. How many functions we can find out from here? Here n of A is equal to 2. N of B is equal to 3. Total number of function exists between A and B is total number of functions exist between A and B is 3 power 2. That is 9 functions exist between A and B. Okay. If n of A is equal to 2, n of B is equal to 3 means total number of functions exist between A and B is 3 power 2, not 2 power 3. Okay. 3 power 2. That is, if A and B are finite sets such that n of A is equal to P, n of B is equal to Q, then the total number of functions that exist from A to B is Q power P. Next, the function is also called as a mapping or transformation. Okay, function another name, mapping or transformation. Now I am giving some examples. First example, X is A, B, C. This is one set. Next Y is P, Q, R. Now A is related to P, B is related to Q, C is related to R. Whether it is a function. Can you say whether it is a function? Already I have explained, no? Whether every element in X have a image? Yes, every element in X have a image. Whether it is unique, A having a image P, B having a image Q, C having a image R. So, it is a function. So, it is a function. It is a function. Why? Because every element in X has unique image. Every element in X has unique image. Therefore, it is a function. Next, second example. 1, 2, 3. Set A. Next, set B is M, P, Q. The relation is 1, M, 2, Q, 3, Q. Is it a function? Yes, it is a function. Every element in, don't see here, this here P does not have a pre-image. Here does not have a pre-image means also a function like that I have explained, is it? Every element in A has a unique image. So it is a function. It is a function. Why? Because every element in A has a unique image. Unique image. Therefore, it is a function. Then the third one, A, B, X, Y, Z. A having a relation is A, X, B, Y, B, Z. Is it a function? Is it a function? It is not a function. Why it is not a function? It is not a function. Why it is not a function? Since B has, the element B has two different image. B has two different image. So it is not a function. One more example. Listen, X, A, comma, X. The relation is A, comma, X. B, comma, X. C, comma, Y. C, comma, Z. Whether it is a function, it is not a function. Why it is not a function? The element C has two different images. So it is not a function. It is not a function. The same reason only. Okay. Next, another one example. Fifth example. Listen, students. A, B, C, X, Y, Z. Here, A having the image X. Next, B having the image X. C does not have a image. Whether it is a function, it is not a function. Why? The element in C does not have a image. Therefore, it is not a function. Therefore, it is not a. Listen, students. For easily remembering this you take as tree. Tree, this is branches. Listen, a tree P has only one branch. Is it possible? Some tree have only one branch. Is it? It will be go directly. That is possible. So it is a function. A tree has, this is tree, this is branch. A tree has only one branch is possible. A P has only one branch. A tree P has only one branch. The tree are also only one branch. Next, here the tree M has only one branch. Next, the tree P has no branch. Some tree has no branch also, is it? Next, the tree Q has two branch, 2 and 3. It is possible. So it is a function. It is tree, branch, like that. Remember that. Next, here, whether it is a function. Listen, students, it is tree, branch. A tree X has only one branch. Next, 2 tree have only one branch. 2 tree have only one branch. Is it possible? No, it is not possible. 2 tree have only one branch is not possible. So it is not a function. Here, students, listen. A tree X has, A tree X has two branches. It is possible. A tree Y and Z has same branch. Is it possible? No, it is not possible. Therefore, it is not a function. Have you all understand about the function? Okay, students. Now, I am going to explain one question. Example 1.6. X is equal to 1, 2, 3, 4. Y is equal to 2, 4, 6, 8, 10. R is equal to 1, 2, 2, 4, 3, 6, 4, 8. So that R is a function and find its domain, codomain and range. First, we can represent the given relations in a which arrow diagram. When we are representing in a arrow diagram, set X, set Y. Set X fully right. 1, 2, 3, 4. Next set Y is 2, 4, 6, 8, 10. What's the relation? 1, 2, 1, 2, 2, 4, 3, 6, 4, 8. Is it a function? Yes, it is a function. Okay, every element in X has a unique image. Okay, here every element in X has a unique image. In Y. Therefore, R is a function. Unique image in Y. Therefore, R is a function. Therefore, R is a function. Next question. And also find its domain, codomain and range. What's the domain? Set X is called a domain. Next, what is the codomain? Set Y is called a codomain. What's the range? Range is what are the elements in Y having a pre-image? That is a range. What is? Listen. First, domain is equal to 1, 2, 3, 4. Next, codomain is equal to 2, 4, 6, 8, 10. Next, range is equal to only 2, 4, 6, 8. Only having a pre-image. That is range. Clear, students? Any doubt? Okay. Okay. Clear, students? X is equal to 1, 2, 3, 4. Y is equal to given this. R also given. Here every element in X has a unique image. Therefore, R is a function. Domain is X. Codomain is Y. Range is only 2, 4, 6. It is called a range. Clear, students? Now I am going to give the homework problem. Does each of the following arrow diagram represent a function? Explain. First, A is equal to A, B, C, D. B is equal to X, Y, Z. A, X, B, X, C, Y, D, Z is a relation. Whether it is a function or not, you have to find out. Here also A and B. Set A given, set B given. The relation is 5, 7, 6, 9, 8, 8. You have to find out whether it is a function or not. Okay. You have to explain that it is not a book by question. It is my own question. You have to do this problem. Have you all understand about the function? Okay. Any doubt in the function? Okay. Thank you, students.